Hello. In this explanation we're going to look at the tangents and the normals, and they are very interesting and also quite basic applications of the derivative. So we already looked a little bit at tangent lines. So if I have any curve fx and we have a certain point A, then we know that we can draw the tangent line by drawing a line that has the same slope as the curve in point A. So this is then called the tangent or the tangent line. It's also sometimes interesting to look at a normal. So that's a line that's not having the same slope, but it's actually perpendicular to the curve at that point. So it has a 90-degree angle, and that is called a normal. And today we're going to see how the derivative can be used to find the equation of the tangent and the normal. Let's start with a basic example. Suppose I have fx, let's say it's 3x squared plus 5, which we all recognize as a quadratic formula, so the graph is a parabola. And let's say we're interested in finding the tangent line for the point x is 2 and then y is 17. Well, in order to find the equation of any straight line, we need to have the slope and the y-intercept. So if you write y is mx plus c, m is representing the slope and c is representing the y-intercept. Well, in this case it's easiest to start with the slope, because the slope can be found by looking at the derivative of f. Because the main application of the derivative, it will give the slope at any point. So let's first write down the derivative. Well, using basic rules of differentiating, you can see that's 6x, 3 times 2x, and the 5 disappears, so we have 6x to be the formula for the derivative. And then look at this point, if x is 2, you can say that the slope, so the m value will be 12, because if you fill in 2 in the derivative, 6 times 2 is 12. So we know now the gradient for x is 2 of the curve, it's 12. So then we can write out y is 12x plus c to be the equation of the tangent line, and then the c can be found by filling in the point 217. Because if you know the coordinates of a point, you can always find the y-intercept. So if you fill in these values, 217, we find 17, it's 12 times 2 plus c. So c is 17 minus 24, c is minus 7. Okay, so that makes, we can write down the equation of the tangent line to be 12x minus 7. Just a small remark in between, or maybe a question to think of. Suppose we're going to look for the intersection of this formula, this graph, with the tangent line. How many points of intersection do you expect? It should be 1, because it's a tangent point, so it has only, it touches the graph only once. And that's actually something that we can check with what we learned about quadratic functions. So suppose we are looking for the intersection. So we equate 3x squared plus 5, we can equate it to 12x minus 7. So if our theory is correct, we would expect only one solution here. Well, what was the method we learned to check the number of solutions of a quadratic equation? Look at the discriminant. So we can do some rearranging first. So we have 3x squared minus 12x plus 12 is 0. Well, you may notice that we can simplify by dividing by 3. So we have x squared minus 4x plus 4 is 0. Well, maybe you see it happening already. So to find the number of solutions here, we can look at the discriminant, because that's the method that we learned. So if you write down the discriminant here, b squared minus 4ac, so there will be minus 4 squared minus 4 times 1 times 4, 16 minus 16, which is 0. So therefore we would say it's one solution, or the official phrasing can be something like 2 equal real roots. And that's actually what we would expect for a tangent line, because it touches the graph, it doesn't really cut it in pieces, it's just one point of intersection. I'm quite sure that many of you, just look at this equation, could see the way it can be factorized, because it turns out that this equation can be written as x minus 2 squared is 0, so it's also very clear there's only one solution, x is 2. So those are a few connections talking about the tangent line. Then let's think about the normal for a moment. There is a special connection when we think of two lines that are perpendicular. So a tangent line and a normal, of course, they are perpendicular, and it turns out there's a relation between the slopes. And in order to investigate, let's look at a basic example. So I would like to consider the line with the equation y is half x. So it has slope half, and if you want to sketch the graph, clearly it would look something like this. Slope half, it means if you go 1 to the right, you go half up. So, for example, the point 2, 1 will be on this curve. Okay, now let's consider the line that's perpendicular to half x. Yeah, so, roughly speaking, something like this. And we would like to investigate the slope there. Well, what happens if you rotate this line so you turn it over 90 degrees? Well, actually, you can say we can rotate the whole triangle here over 90 degrees, and we end up with a triangle that's 2 up and 1 to the left. My sketch is not completely accurate. But if the whole line is rotated over 90 degrees, you can say, well, okay, so then also this triangle over there, it turns to a triangle over there. And then it's not very difficult to see the slope of this line that is normal. You go 1 to the side, and you go 2 down, so the slope is minus 2. And so the equation of this line will be minus 2x. So for the first line the slope was 1 over 2, and then for the other one it was minus 2. Well, it turns out there's always a special connection. If two lines are perpendicular, there's a special relation between the slope, and many times that's described as the negative reciprocal. So if you start with half, you can take the reciprocal, so you turn it upside down, so 1 over half, it's 2, And then you also change the sign and it becomes minus 2. So the rule can be summarized like this: the slope of the tangent times the slope of the normal must be minus 1. So that's something to keep in mind. It's sometimes called a negative reciprocal, as I said before. So if you start with half, it becomes minus 2. If you would start with 2/3, for example, and you take the negative reciprocal, it becomes first 3/2, and then also it changes the sign, so minus 3/2. Okay, let's do an example where it is asked to find the equation of the normal. So let's consider gx is square root x, and let's say we're looking for the equation of the normal, let's say at the point 9, 3. So we can easily check that's a point on the curve. If you take x is 9, the y is root 9 is 3, and we're looking for the equation of the normal. Well, like in the previous example, we'll first need the derivative. So let's calculate the derivative. Since root x can be written as x to the power half, we can apply the power rule. So therefore the derivative, it's half x to the power minus half. And it's very common to rewrite that a little bit, so we don't have the fraction in the exponent anymore. So we have half times 1 over x to the power half. So half times 1 over root x, 1 over 2 root x. Well, this derivative occurs quite often, so actually I would recommend to just memorize it. So if you start with root x, the derivative is 1 over 2 root x. Okay, now let's see how we can use this to find the equation of the normal. So the normal, again, will be a straight line. So I just start with writing mx plus c. Notice that it's almost like a recipe. You just go through all the steps, and if you don't make a mistake, you find the equation of the normal. So look at the slope, and we can start with the derivative. If you take the derivative, so you take the g dash 9, because we talk about x is 9, we have 1 over 2 times root 9, so 1 over 2 times 3, 1 over 6 is the derivative for x is 9. So that will be the slope of the curve at that point. But that's not a norm, because this will actually give the slope of the tangent. So now we can use the rule we discussed earlier. So therefore the slope of the normal will be the negative reciprocal. So it will be minus 6. So 1 over 6, you first take the reciprocal, which is 6, and then it becomes minus 6 as the slope of the normal. And then we can continue to find the c value, and we do that by filling in the point. So if that's still the same point. So if x is 9, the y should be 3. So if you fill in that point 9, 3, then we can say that 3 is minus 6 times 9 plus c, that's minus 54, so c is 57. So y is minus 6x plus 57. And I would recommend you can make the sketch or plot it on your graphic calculator, and you will actually see that they are perpendicular. So roughly I would expect the graph to be something like this. We know that root x is this shape, and then a 9, 3 to be the point, and then the line, the normal perpendicular, slope -6, so it will intersect the y-axis somewhere at 57. So this is showing how you can find the equation of the tangent and the normal.